In the next problem we have a graph of f, and it consists of 3 line segments, and g is going to be the function given by g of x is equal to the integral from -4 to x of f of t dt. So we want to find the value of g of -1, g prime of -1, and g prime prime of -1, or state that they don't exist. Well, g of -1 is the integral from -4 to -1 of f of x dx. So all we need to do there is to find the area under the curve from -4, or between the curve and the x-axis between -4 and -1. That's a trapezoidal shaped area with a height of 3. One of the bases is 4 and the other base is 2. So the area there should be 9, or the integral from -4 to -1 is -9, because that lies below the x-axis. Now how could we have made that, have the math come out to say -9? I should have used -4 for one of the heights of the trapezoid and -2 to be the other height. Then we would have gotten -6, and when we multiply it out we would have got -9. So that's for g of -1. Now g prime of -1 is the derivative of the integral from -4 to x of f of t dt evaluated at -1. Remember, we don't plug in the -1 until after we take the derivative, just like with regular derivatives. Well, we do know that the derivative of the integral from -4 to x of f of t dt by the second part of the fundamental theorem of calculus is just f of x. We want to evaluate that at -1, then that's just f of -1, and f of -1 is -2. Now, second derivative is just the derivative of the first derivative, which was f of x, and so we know that that's just f prime of x, and evaluated at -1 is f prime of -1, and that gives the slope of the curve at x equals -1, which does not exist because of a sharp turn. But in this case they don't ask us to demonstrate why or to justify why. So we have -9, -2, and does not exist for the first part. Alright, for part B, we want to find the points of inflection of g of x. And g of x has a point of inflection where g prime prime changes sign. Since g prime prime is just f prime of x, which we saw on the previous step, then we want to find the places where f prime of x, or the slope, changes sign. We can see that from -4 all the way up to +1, the slopes are positive. Only at x equals 1 does the slope change sign. So since g prime prime of x is f prime of x, g of x has a point of inflection when f prime of x changes sign, and that only occurs at x equals 1. Now in part C, we have a new function, h of x, which goes from x to 3 of f of t dt. We want to find all values between -4 and 3 for which h of x is 0. So you want to think of 3 is going to be your ending point here. And you want to go backwards from there until you get a net area of 0. So you can see as we move back from 3 to 2, we have a negative area. From 2 to 1, we have an area where the positive is going to cancel with the negative there. So at f of 1, we actually have, or h of 1 rather, should equal 0. I hope that makes sense. So we start, if we had from 1 to 3, the integral from 1 to 3 is definitely going to equal 0 because we have canceling parts there. If you continue to go back to 0, now you're going to have more positive than negative. If you go back to -1, now the area between -1 and 0 cancels with the area between 0 and 1, and then from then on it cancels again. So at x equals -1, at x equals -1, h is also 0. But you can see from that point on it's going to be more negative than positive.